Hello, good day, and welcome to Thinking and Working Scientifically. In this series, we are looking at Cambridge checkpoints and Pearson Edexcel syllables for both primary checkpoints and junior secondary checkpoints and Pearson Edexcel exams. Today, we are looking at materials. Particularly, we shall be considering dissolution of solid in liquid. Let us get thinking right away. What happens when a teaspoon of sugar is dropped into a glass filled with water? Eventually, the sugar dissolves and the water looks clear. How about a salt dropped into a glass filled with water? Again, eventually the salt dissolves and the water looks clear. Now we are thinking. These are examples of solution. In the first case, where we have sugar in water, we have the sugar solution. As you can see, this is sugar in water. After a while, it looks this, clear. This is sugar solution. In the case of the salt in water, we have the salt solution. Look at it looking clear. One thing you would observe is the water you can see here doesn't seem to contain salt anymore, but the salt is there, but you don't see it. What happens? The salt is mixed with the water. The same thing here. Now, the sugar dissolves in water, so the sugar is called a solid, while the water which dissolves the sugar is called a solvent. In this case, the salt dissolves in water, so this salt is called a solid, while the water which dissolves the salt is called a solvent. So we have the sugar solution and the salt solution. Now the question is, what is a solution? It's very simple. Look again at what you have here, the sugar solution. This is sugar and water, but it looks uniform. Look at this. This is salt solution, but it looks uniform. So from this appearance, in science, it's very important we have pictures in our mind. So we really don't need to memorize definitions. All we need to do is see the picture and we can always define or explain anything. Based on this picture, let's define what a solution is. It's simple. A solution is a homogeneous or uniform mixture of a solid and a solvent. Please, you may want to repeat it. Let's go together. A solution is the homogeneous or uniform mixture of a solid and a solvent. Okay, the solid plus the solvent would give us a solution. So in our first example, sugar and water would give us the sugar solution. So that's sugar being the solid plus water being the solvent to give us the sugar solution. In the case of salt and water, salt, which is the solid, plus water, which is the solvent, gives us the salt solution. Now you would observe that both the sugar and the salt dissolve in water. So this takes us to another very important aspect: soluble and insoluble substances. If a substance is soluble in a solvent, it means it dissolves in the solvent. So soluble substances dissolve in a solvent. Okay? For example, sugar and salt are soluble substances in water. Now, the opposite of soluble is insoluble. So, in other words, insoluble substances do not dissolve in a solvent. For example, sand and flour, or baking flour, are insoluble in water. Yeah. Instead, they form what is called suspension. So while soluble substances form solution, insoluble substances form suspension. Take note of that. Insoluble substances form suspension in a medium. It's very important. So now you know the difference between a solution and a suspension. You know what soluble substances are, and you know what insoluble substances are. You also know what a solid is and what a solvent is. So let's look at this example of suspension. We talked about sand in water. After a while, this dissolves to give us this. Rather, reduces to this. So you say the sand doesn't dissolve, but it stays at the bottom. So we say the sand remains undissolved. How about that of the flour in water? You can see this. The flour doesn't dissolve. The flour remains undissolved. So in a suspension, the insoluble substance does not dissolve. It remains undissolved. It's very important you know that. While in a solution, the soluble substance dissolves. In a suspension, the insoluble substance does not dissolve. While in a solution, the soluble substance dissolves. In a suspension, I repeat, the insoluble substance does not dissolve, while in a solution, the soluble substance dissolves. Okay? Alright, now we are ready. What happens during dissolution? The salt and the sugar dissolving in water. What really happens? This will take us to what is known as the particle theory. You must have learned this about the states of matter, solid, liquid, and gas, and how the particles are arranged. So the particles theory helps us to understand how particles are arranged and how they behave or move in the medium. We have this. For a solid, the particles have a regular structure and they are closely packed together. In a liquid, the particles do not have regular structure. They are not closely packed together, but in a gas, the particles are far apart. Look closely again. This is the particle model for a solid. This is for a liquid, and this is for a gas. How does this help us to understand dissolution? Imagine what happens if these particles bombard these particles. What will happen? Of course, they're going to knock these particles apart, and if these particles are soluble, eventually these particles will absorb them. Let's take a look at this closely. Watch what is happening right here. This is sugar dissolving in water. You can see the sugar particles in the through the magnifying glass. Look closely. See the sugar particles spreading apart by the water particles. See what is happening? This is exactly what happens during dissolution. So now you know it's science time. So for what keywords have we learned? We learned solution, solutes, solvents, soluble, insoluble. We learned what? Dissolution and suspension. So now we are good to go. Remember, this is Maths and Science Clinic Daily for children ages 7 to 14. Feel free to reach us through the WhatsApp contact on the screen. Visit our social media handles, Facebook, Maths and Science Clinic Daily, and please follow us on Facebook and on YouTube at Maths and Science Clinic Daily. One word, just search it on the YouTube search bar. You would see it there. Please subscribe to our channel. Thank you. So you get daily update, and remember to click on the notification bell. Thank you. Let's move on right away. Here we have a question that will get us thinking. Investigating how quickly salt dissolves in water. Rajput and Clinton are investigating how stirring affects the rate at which salt dissolves in water to form solution. They follow these steps. 1. Pour water into 3 beakers labeled A, B, and C. 2. Pour salt into each beaker. Do not stir beaker A, stir beaker B slowly, stir beaker C quickly. 3 things are to be done. In the first beaker, nothing is done. Don't stir. In the second beaker, which is beaker B, stir slowly. In the third beaker, stir quickly. So what's the third thing to do? Time how long it takes the salt in each beaker to dissolve completely. Let's look at this simple setup. Beakers A, B, and C. Beakers A, B, C. Okay? So let's go to answer the questions that follow. A. What is a solution? Can you recall that? Try to remember the picture of a sugar or a salt dissolving in water. What do you see? So what is a solution? Simple. A solution is the homogeneous or uniform mixture of a solute and a solvent. You can repeat that definition. A solution is the homogeneous or uniform mixture of a solute and a solvent. B. Identify the solute and the solvent in this investigation. In this investigation, which substance dissolves? That is the solute. Good, it is salt. Which is the medium or the substance that dissolves the salt? It is water. Beautiful. So water is the solvent, salt is the solute, water is the solvent. We go to question C. What laboratory piece of apparatus would they use to measure the time? It's very simple. That question is asking you, what do we use to measure time in the laboratory? It is stopwatch. Correct. Let's go to D. State three things Rajput and Clinton should do to make sure the investigation is a fair test. What does it mean for an investigation or an experiment to be a fair test? It means that all the variables involved or all the setups are given equal conditions so that no one setup has better conditions than the other. That way we can truly investigate the condition or the variable we are actually looking out for. The other conditions are kept constant, the same for all other setups. Like in this case, we are actually changing the rate at which we stir. In beaker A, we don't stir. In beaker B, we stir slowly. Beaker C, we stir quickly. So what do you think we must do to all in order to ensure that our experiment is fair, our investigation is fair? One, you should know this, that you should measure equal volume of water into each beaker. So one beaker doesn't need to have more water than the other. The water volume must be the same. Two, the temperature of water in all the three beakers must be the same as well. Okay? The temperature has to be the same. Then number three, the amount of salt or the mass of salt you put into each beaker must also be the same. So these three conditions are very necessary to ensure the investigation is a fair test. One, measure equal volume of water into each beaker. Two, ensure temperature of water used in each beaker is the same. Three, measure equal mass of water into each beaker. Let's go to question E. How can they make the results of their investigation more reliable? If the results of an investigation is reliable, that means the results are dependable, the results are trustworthy. And to have a reliable result, it's very simple. All you need to do is repeat that experiment a number of times. That's just simple. All you need to do to repeat the experiment a number of times. So what they need to do is repeat the experiment a number of times. F says they carry out their investigation to ensure a fair test with reliable results. Here is the table of results. Study this table closely. No stirring. See the time it takes. Very high. Stirring slowly. High but slower than no stirring. And stirring quickly. Low. And look at the average. You add this test 1 to 4. Divide by 4. You get each of those. Now what's the question? State the independent and the dependent variables in this investigation. The independent variable is the variable that is not affected by other variables here. But in this case, stirring action is an independent variable, which is the rate of stirring. So that's the independent variable, the rate of stirring. While what depends on this rate of stirring? The time taken. Look at it, the time depends on the rate of stirring. So the time taken to dissolve is the dependent variable. Now we go to G. What conclusion can you draw from these results? It's simple. As the speed of the stirring increases, the time taken to dissolve reduces, which means dissolution occurs faster when the speed increases. Okay? So it's very simple. Conclusion is the rate of dissolution of salt in water is affected by stirring, which means the quicker the water is stirred, the faster the salt dissolves. You can see that from the table again. Okay, we move on to H. State two other variables that can be investigated for how they affect the rate of dissolution of salt in water. It's very simple. These variables are the temperature of the water and the volume of the water. We can change this and see how they affect the rate of dissolution. So at this point, trust you've learned something from this video. You can pause it, repeat, and watch over and over again. Then please, this is your turn. Use the particle model to explain the results obtained by Rajput and Clinton. Thank you.